Hello! We're going to be doing the Junior Math Challenge. Year 8 or below. I think last year managed to do it mad speedy. So let's see if I manage to do this one mad speedy. No idea. I'm going to give myself 60 minutes because that's how much people get. And let's see what happens. So 3, 2, 1, and go. Oh, our time is starting slowly. Okay. That's 26. That's 14, that's 46, that's 34, that's this one, so it's 46. Nice. 4 squares with the length of perimeter different. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this guy. What's the value of this? Okay, 4 minus 3 is 1, minus 2. I can actually take out minus 1, and then it's 4 plus 3 plus 2 plus 1 over 8 plus 7 plus 6 plus 5. I mean, it's kind of fun. That is 10 over, and that is 15. Wait, what? Oh, I've messed up. Mess up on question 2. Okay, let's just do the math. That's 1. Wait, what am I doing? 1 minus 2 is minus 1. That's minus 2. That's 1 minus 5 minus 10. That's a fifth. Oof, number half a number. Remember, half of the number plus a third of the number plus a quarter of the number equals 52. What was the number? Let's times everything by 12. By 12. So that's 6x plus 4x plus 3x equals 52 times 12. That's 13x equals 52 times 12. That's divisible by 13. So x equals 4 times 12, which is 48. Fun, 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 fun. Salisbury's clock, thought of our oldest striking clock. Holy moly. So that's 80 years. So 80 times 350, let's just do 400, times once on the hour, every hour, yeeks. 80, 400, then that's days, then that's hours. Oh, okay, so let's do that. So that's 1, 2, 3, 4 zeros, and then 640,000. 600,000. Ada likes adding numbers. Who doesn't? Let's go, Ada. Okay, she adds 110 plus 101 plus 111 plus 100. Yeah, either 2 or 3. Oh, I think that you can actually do this in an easier way, but 2, 3. Oh no, 2 digits. Oh, thank God. Yeah, I think you can do this easier, but it doesn't matter. 1, 2, 3, 4, 5, 6, 12. 1, 2, 3, 4, 5, 6, 7 plus 6. 13. 1, 2, 3, 4, 5, 532. Nice. Ask right 296 is the sum of the list of 5 different primes. Okay, so if I've got odd plus odd plus odd plus odd. Okay, all odds would make an odd, which can't make 26. So we have to have a 2 involved, so 2 is the smallest one. Has to have a 2. As in, so there's one possibility, and that possibility is 2. Ah, that's a nice question, because I can imagine people flapping around with it and not realizing it's just odds and evens. Okay. The area of this is 9. Oh, that's 3, 3, 3, 3, x y, y. The rectangle, okay, so 1, 2, 3, 4, so 12 plus 2x plus 2y, so it's pen smaller. 12 plus 2x plus 2y equals 30, so that's 6 plus x plus y is 15. But the question is TVWR, which is 2x plus 2y, great question, so that's 18. 2x plus 2y is 18. Oh, great. This Junior Maths Challenge is hitting so far. I'm enjoying it. Oh my god, what's with all these factorials? Counts in a curious way. Starts at 1, then always miss out multiple 3, multiple 5. One I would say when he counts 15 items. I don't know, 1, 2, 4, 6, 8, 10, 11, 13, 14, 16, 17, 19. This feels like a stupid way of doing it, but I'm just going to do it. 20, 22, 23, 26, 28, 29, 31. How many numbers? 15. 1, 2, 3, 4, 5, 10, 11, 12, 13, 14. No idea what's going on with that question. Seems a bit boring. Kite. Okay, so that's 85. Parallelogram, HIJK. So that's 80. So that's 80. So that's 100. Let's chuck a little 100 in here. So that's 80. So that's 100. IFG, I imagine, yeah. So that's 360 minus 170. 170 minus 80. Wow, this pen's still big. 360 minus 1 minus 250, 110. Check I haven't messed that up. Yeah, that's fine. How many ways? 3x3 grid. So that the sum of the numbers in each row is even, and the sum of the numbers in each column is odd. Okay, so we've got 1, 2, 3, 4, 5. 1, 2, 3, 4 evens and 5 odds. So odd, even. We need 3 odds in the columns. It's the only way to add things up to make an odd. Oh no, it could be even, even, odd. Even, even, odd. Okay, let's do this. Where the things are doesn't matter. So we need even, even, odd. Then this even number, we need somehow this to be even, even. Like, you have to have that. If you go on even, oh no, you can have 2 odds. If you have an even, you need 2 odds. Then you need even, even. Now that's odd. What's going on here? I don't think it works. I don't think it works because I can't seem to do it. I feel like it doesn't work. That's an interesting question that I'm not sure. You know what? I'm going to make a weird play here. This is harder than usual. There's one line of symmetry. Okay, he can eat that. Then 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 he can eat that. And that's it. Oh no, no, no. Then he can eat that. 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 He can eat that, 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 and that. And that's it. 1, 2, 3, 4, 5, 6. Ooh, that's cool. That's cool. Let's just play around and try that another way. Oh, what a great question. 1, 2, 3, 4, 5, 6, 7, all of those. Then the diags. Then the diags. Yeah, and then we're left with this thing that's kind of interesting that we can't deal with. Oh, what a great question. Okay. 10p plus q plus 10p plus r is 75. This is 75, so 20p plus q plus r was 75. Oh wait, these have to be 30. P has to be 3. And these have to add 15. So it's 3 plus 15 is 18. Oh, that's cool. That's cool. That's cool. That's cool. That's cool. That's cool. Yeah, this match run's absolutely hitting right now. Really fun. Also I think hard. That's the point in the base. The perimeter of triangle PQR is 80. The perimeter of triangle RPS is 44. A, B, C, D, E. Okay, so we've got the perimeter of PQR. A plus B plus D plus E equals 80. RPS. A plus D plus C equals 44. RSQ. C plus B plus E equals 60. What's RS? C equals. This feels like a classic add everything together and see what happens. Yeah. 2A plus 2B plus 2C plus 2D plus 2E equals 100. The most classic math challenge trick of all time, by the way. All time. 184. So A plus B plus C plus D plus E equals 92. But we know these guys equal 80, so this guy has to be 12. I mean, unreal question. So fun, so easy. I mean, like, the most math challenge question of all time. Every time I'm so impressed by how they can come up with a new question of the exact same technique. That's pretty cool. That cube, when it's fully correct cube, each arrow points to an adjacent face. Each arrow points to an adjacent face. Some of the triangles on those faces. This guy's going to point to 1. Or isn't this guy also going to point to 1? Nope. Oh, it's going to point to that 5. This guy's going to point to 5, although I don't love that. Okay, that's a 1. I can place a 6 or a 2, I guess. 2, I can place a 3. 6, I can place a 5. Oh, where am I going to put the 4? That doesn't work. One. No. 6, 4, 2. 6 and 4. 6 could go with 5. 4 can go with 3. And I've got 2. Okay, nice. D1s. Okay, so if he writes a 1, he can't start with a 0 basically. If you're a run, then he could write a 0, then he could write a 1, 0, 1, 0. You can also write 1, 1, 0, 1, 0, 0. You can also write 1, 1, 0, 0, 1, 0. You could also write a 1, 1, 1, 0, 0, 0. Yeah, if you start with a 1, and I'd start with a 1. So if there's a 0, next one has to be a 1. If you start with a 1, next one could be a 1, in which case it could go 0, 1, or it could go 0, 0. And if it's 1, 1, 1, so 1, 2, 3, 4. Cool, really fun. Okay, we'll be speeding. We're nearly at the end, but it obviously gets harder. What the heck? Well, someone say this can be true. Okay. A is saying she's more than Bob, which is more than Cat, which is more than D. Cat is saying she's more than D. D is saying she's more than E and more than Amy. Oh, Dan and Amy, you lying right now. Eve has more than Amy. Oh no. So if Amy's wrong, if Amy is the smallest, then we have Bob has more than Cat and more than Dan. Cat has more than Dan. Dan has more than Eve and more than Amy. You have more than Amy. So Eve is wrong. So 4. Got lucky there. Very lucky. PQP. Oh, that's 100. QP equals QS. RP equals this. A, B, C. Okay, so A plus B plus C equals 100. D, D, E, E, B, D, E make 180. So that's 180 minus E, that's B plus D. That's B plus D. That is C plus E. What are we trying to do? TPS. Oh no, it's RP equals RT. QP equals QS. Oh, it's these two. Okay. That's A. That's B. That's B. Then that's C. That's C. That's D. Okay. That's okay. So B plus C minus E equals 100. B plus C plus E equals 180. So that means if I subtract these, this minus this, 2E is 180, 280, E is 140, which is of course impossible. B plus C B plus C minus E equals 100. B plus C plus E equals 180. If I subtract it, well, it's subtracting 80, E is 40. It took a bit longer than I wanted, but it's fine. chocolate. Let's do the last letter. Chocolate, cherry, cream, coffee. For every 7 chocolate cakes, there are 6 cherry. For every 5 cherry, there are 4 cream. For every 3 cream, there are 2 coffee. Okay, so we need some lowest common multiple shenanigans. So that's, if I times this by 5, that's 35 to 30. That going to 30 is times by 6, that's to 24, that's to 16. And this adds to 65 plus 40, which is 105. That's 35 to 30, which is 30 to 24, which is 24 to 16. So that's 105. So looking for multiples 105. 210, 315. Can I simplify this? No. 315. 420. Ho ho, 420. Fun. Okay, we're making good time. What's the smallest number of rectangles which can be fitted together without gaps to form a rectangle side length in the ratio? Hmm? One, 2, 3, 4, 5, 6, 7 makes 30 to 35, which is 6 to 7. Then if I add another one here, (30 to 40), which is 3 to 4. Oh, I'm trying to make this 4 to 5. Okay, 4 to 5 is 30 to 24, which I can't do. But 30, I could do 60, and then I need 15 of those. Can I make this guy? I'm going to leave this one for now, come back to it. I'm thinking 60 to 75, but I'm not sure. Frogs, 4/5 green, 1/5 black, 6/7 of the snakes, 6/7, 1/7, 1/7 green, 6/7 black. There's got to be 35 frogs. Frogs and snakes. 4/5 of the frogs are green frogs, 6 of the snakes are black ones. If it was 22, we need a multiple of 5 and a multiple of 7. Yeah, so that works. This can't be made with a multiple of 5 and a multiple of 7. This one can. This one how can you make this with a multiple of 5 and a multiple of 7? Oh, 5 plus 21. I think it's this one. Because you can't make that with like 5 plus 18, 10 plus 13, 15 plus 8. Yeah, I think it's that one. Interesting. Yeah, it's like 5n and yeah, 7m. 5n and 7m has to equal to those numbers. Mean of the first 4 numbers. Okay, so a plus b plus c plus d equals 20. B plus c plus d plus e equals 28. The range, now we subtract them, is e minus a, which is 8. That's easy. I just subtract those. Nice. 9 squares arranged, they form 2 lines. 5 squares. The squares we times positive integers, so the total of 5 numbers are equal. Okay, so altogether, the numbers 1 to 9 add to 45. 20, 30, 45. So that's got to be a 5, doesn't it? Isn't that just... No. But if the other one's round to 45, this makes 17. Okay, if it was in the middle, this one, 9 was in the middle, then they have to add to 36, and so each bit has to add to 18, so that would be 11, 11, 17, 18, and then can't it just be, so it can definitely be 9. Can't it just be all of them? If I get rid of 1, then we've got 44, then things need to add to 22. And 14, 18, so that would be a 4. I got rid of 4. Okay. In the case where there's 9 in the middle, that works. In the case of 1's in the middle, then I have to get rid of this and this We've already used this and this and this. So I've got 9, 7, 5, 2. Does that add up to 22? No. So I think 1 doesn't work. Can't be 1. Can be 9. Can't be 8. Can't be 6. Can't be 3. If it's 2, then it needs to add 43, and that can't work. It has to be an odd number. Can't be those. So 5 and 7. Did 1 really not work? 10, 20. Oh no, they need to add to 21. Did this add to 21? 16 plus 7. No, it didn't add to 23. Okay, if it's a 5 in the middle, if that's a 5, there's definitely a clever way of doing this, but I'm just flapping around. Then they need to add to 40, so each bit needs to add to 20. So that's 11, but no, that's already too big. So that can't go there. If I put a 7 here, no, this is there's no way I'm doing this right, because the sum of the values is going to be way smaller than this. That's a 7, then everything else had to add to 38, which means each bit needs to add to 19. Oh wait, let's try that 5 again. I think I messed that up. 4, so yeah. 8, 11, 17, and a 3. Then we need the numbers, so we need 1 plus 2 plus 9 plus 7 to add to 20, and they don't. So 5 doesn't work. Oh no. If that's a 1, then everything has to add to 22. That's 12, so that has to be a 4. Oh no, I keep forgetting that I keep adding the number in the middle and I'm not meant to do that. That has to be a 5. And then I need to know, does 6 plus 7 plus 9 plus 2, does that equal to 22? No, it equals to 24. It's not 6. Oh my god. It's 4 plus 7 plus 9 plus 2. That does work. Okay, so 1 works, 9 works. I think all the odd numbers are going to work, and I've just been silly. If 5's there, they have to add up to 20. That's 11. 11 add 6 is 17. Oh no, that doesn't work. That doesn't work. But I think 7 will, so I think it's 17. We've taken a risk. We've taken a risk. That's such a shame. I was actually speeding into these last ones. Yeah, the first so there's many, at most 2 tie the finish line. Okay, so there's the total combinations of all of them. If it was 1, 2, 3, 4, is this, which is 24. But then, if we have 2 finishing at the same time, then we have this. Then we have 1, 2. Then we have 4 choose 2 of going in this first one, which is 4 times 3 divided by 2. So there's 6 options for pairs of winners, and then there's 2 different, then there's 2 and 1, so there's 12. So it's 36, which is wrong. Okay. There's 6 different ways to choose 2 things from 4. A, B, B, C. A, B, B, C, C, D, D, A. A, C, B, D. Yeah, 6 options for the first one. Then, if that's a pair, then the other 2 people, there's 2 options for who came there. PBOA. So there's 12. And then there's 24, and that makes 36. Okay, the different ways they could finish is just how many ways can you arrange A, B, C, D, which is just 4, 3, 2, 1. But then, if there were 2 at the finish line, then we could have, there's 6 options for who those people were, and then there's 2 spaces left. Oh, but I guess we could also have, that case where 2 people finish second. Yeah. 2 people finish there. So we also have the case where we've got 6 more cases basically. 24, 12, and 6, which also doesn't work. Huh. Oh, no. At most 2 tied on the finish line. We could also have, okay, so we've got no, okay. Case 1, no one ties. We've got A, B, C, D, all those different ways, and that's 24. Case 2 is that they tie on this first one, which means that there's 6 times 2 times 1, which is 12. Case 3 is that they tie, which is 6. There's just 6 options there. Because if it's A, B, then it's C, D, it doesn't matter. Then there's also the case where there's one person winning, 2 draws, and then another one. Oh, I think it's going to be 60, but I don't quite see how. But I've definitely got more than 30, because I could have this weird option where I have 4 options for here, and then in this slot I've got 3 choose 2, which is 3, and there's 1 person left, which is another 12. What does this add up to? 54. Yeah, I think it's 60. I've not got all the cases, but I think it's 60. The only one I haven't done is 21. Five by 30. 4 to 5 could be, yeah, we said it could be 60 to 75. To get 60 to 75, that means we had 15. Okay, I can't put 1. I think it's 30. I think you just do 15. I think you do like 15 long. I think it's 30. Okay, and we're done. Oh, I stopped instead of paused. Okay. Very enjoyable actually. I think quite tricky. 11, I'm not sure that was right. But I had a great time. If you enjoyed that, yeah, 25 is one I'm going to try actually playing Maths one other time, but I don't have time right now. So, thank you so much for watching. That was very enjoyable. Actually, a great math challenge. I thought, once again, tricky. Like, they're making these challenges trickier than usual, which I'm into. Thanks so much for watching. See you in the next one.